I think so. One of the key things, while people figure out, some of the questions they might want to ask, I think one of the things that's very exciting to see across all the presentations that we've already seen, and one of the reasons we wanted to have this kind of future direction topic, is that there's a lot of work on, there's clearly a lot of work on trying to improve or develop new understandings of deep sea processes and develop the depositional models that might be associated with those. One of the kind of benefits of obviously having those, and in conjunction with all the work that Celeste and Arif are doing, as well as Florian, is to understand, well, key things like organic carbon, micropollutants, where are these things going? If we have incorrect depositional models about where these things are occurring, the lateral extent, the spatial extent of how big these deposits that they're associated with could be, we might be having completely skewed models for that carbon budgeting and that burial of pollutants. And so I think one thing that this has really shown, and that we really wanted to communicate, in addition to what the presenters have just done, is that there's actually a lot of active questions. And I think there's a lot of active interest right now, as we see throughout the community, on exactly these topics. And I see that there's a couple questions that just appeared in the chat on my end. I can't click any of them. Lilian, I didn't know if you were able to click on them.
Yes, I can see some. We have one of the first question is Brian Romans from the Virginia Tech, and he's saying, Javier, thanks for sharing. I agree with you that a critical next step is to link actual measurements, the bottom currents velocity, with the deposit character. To do this will require a significant investment, and he referred to the Hubble project in Nova Scotia, and margin, and it took place in the late 70s and early 80s. That was funded by the US Navy, but they aren't as interested in this expensive deep ocean field work as much these days. So where does our community go to seek the necessary funding to do this work? With whom should we sedimentologists be developing big proposals with? Would you love to hear your thoughts? So this question is for you, Javier.
Okay, well, very good question. Yeah, I know that project, and it was a pioneer project for understanding many deep marine processes. Well, the only way is to try to have international projects, to collaborate more between us, and this is probably the only way. I know there is a couple of groups working in this topic, mainly to understand the benthic boundary layer and the processes above the seafloor. Probably in coming year we will see more and more, paper about that. But this is the only way. I do agree with your comment. The only way. It's quite expensive, but it's the only way. I mean, you have so many theoretical models that they are really working, and it's because they are based on the facets from the ancient record or from the ancient record, but we don't really know the processes behind. So that's the challenges for future.
There is a comment from Ole Martisen, and it was just to say hi to Arif, and he said just very nice, and he unfortunately he has to leave. And he was the same with Bill Arnott, and he has to teach, and he mentioned it, and he said that he likes the first two talks, but he has to go, sorry. We have a question from Marco Fenesso to Arif, and he is, Arif, thank you for your excellent talk. I just wonder why in your penultimate slide you associate HEVs as a result of the pure laminar flows and not as in part of the evolution of the turbidity flows entraining mud, or rapidly decelerating and collapsing as they are commonly interpreted, as suggested by your introduction schemes.
Thanks, Marco. Lilian, for some reason, I couldn't understand the question fully. Could you please repeat it?
Yeah, so he just wondered, and in your one of your last, the penultimate slide.
Okay.
The associated HEVs it looks like he's a result of the laminar flows.
Mm-hmm.
And he's wondered, and it doesn't, it looks different from your introductory slides.
Okay, perhaps I would, I don't know, Marco, if I understand your question correctly. I'm really sorry about that. Why not write to me and we can take a discussion from there, if it's okay. You know, because
Yes.
what I understood is I have divided the laminar flow divisions like H3 into two parts, you know, based on our XRF work, if I understand it correctly. Yeah, but sort of we need to simplify the things, as hot and mod is already, you know, widely understood. So sort of linking up with it. If I understand it correctly. Otherwise, I'm really sorry. Could you please get in touch with the through the email? Yeah, please.
So yeah, so sorry, Arif, I'm going to go back again. It's just that he's wondered, and in the, you know, at the beginning you showed, and these HCPs were associated with the evolution of the turbidity float. You have some processes like entraining of the mud and the accelerating and collapsing of the flows. Then in the last slide, it was something showing more like as a result of the laminar flow. So
the cartoon was just, you know, to simplify and to compare the fractionation of organic carbon into the parts of the hybrid beds. Yeah, and hybrid beds can lock the organic carbon content in slightly lower tiers, while turbidites can lock it up into the upper tiers where they are prone to, you know. So it was just a simple sort of comparison. Yeah, but perhaps there is scope to discuss, so we can chat through email if it's okay.
Okay, wonderful. So we have a question that is for Celeste and Arif, and is Kate Gills, and she is asking, how and when does the carbon becomes attached to the clays? So is whether it's on the shells and then it's transported with the clays, or during the deposition has clays and suspending has organic matter flocculated together?
I think it began when sort of clays began to, if organic matter is completely dispersed in the column, and when clays began to flocculate, there is organic carbon, so it may get attached to it. So it could be just at the onset of flocculation process. Definitely, some of the organic carbon can be sort of, you know, sort of transported with this mud class, which is already incorporated, which is part of the mud sort of class structure. So I think it's onset during the onset of flocculation.
I would agree with that as well, and I think yeah, this would begin on the shelf, and as these flows travel down slopes, they can also erode the seafloor out and re-entrain both clay and any pre-deposited organic matter that can then have the chance to become flocculated again with all the clays in the flow.
So we have one question from Jacobas, and he is specifically directing it to Arif. You showed a contrasting vertical distribution of the TOC in the turbidites and in the HEBs. Can you say more about the horizontal distribution of the TOC in the deposits of these different flow types?
Hi, Echo. Thanks for the question. At this stage, perhaps, no, we haven't sort of studied it. Yeah. But this is something perhaps we need to do in the future. Yeah.
Okay, this is super interesting. So there is still a lot of work to do. We have a question for, sorry if I mispronounce your name, Surtri Reka Sahu. And it's, hi all, my question is for Dr. Paul. And so can you emphasize on the source of the marine plastic pollution? Thanks and regards on Dr. Srutri Rekat Sahud, assistant professor for is in the Saudi Arabia University.
Yeah, hello. Can you hear me okay?
Yes.
Yeah, okay, cool. Yeah, thanks for that question. And so input sources are basically rivers, shorelines, also fishing, but it all comes down basically to mismanaged plastic waste. So it's just that people throw away their waste into the river, or there is no waste system in place, or also that rich countries simply export their plastic waste to other countries to get rid of the problem. So I think the main source, you could say, it is mismanagement of plastic waste, as a mismanagement.
Okay, sorry, I have to make a small correction regarding to Sutri. He or she is from the Fakir Mohan University in Balashore, Odisha, India. So I thought that it was a different place. We have a question for Fabien, and it's a Brando Prater, and he is should or could this community assemble and share contour drift calibration database?
Oh, that's interesting. I mean, I think that might be more, you know, a kind of a question to actually, in a way, you know, most of the presenters. I think there's a lot of active work being done on contourite drifts, right? There's a lot of interesting shallow data, modern data that can maybe be used to actually help kind of build these. And I think with the points that were made today, just understanding the key drivers behind some of those processes and then the deposits they create, that could actually potentially be a very valuable thing for the community to have, is, you know, a database on those large scale deposits that are potentially so responsive at a faster rate to some of the processes that we're seeing. They could also be used, you know, along the lines of what Florian and Celeste and Arif have been talking about today. That might actually help us start developing more robust depositional models, because those could be some pretty big storage tanks for organic carbon or microplastics. So I think that'd be a valuable thing to discuss, and kind of in connecting that to just some of the larger, I guess, goals, you know, as the scientific community in general moves towards more open source data, open source databases, and being able to leverage, you know, more analytical approaches. We need data. We need data that's centralized, and we need data that's accessible and can be something analyzed. So I think that moves along with where the scientific community is going in general. I don't know if anybody else, any of the presenters or Lilian or Emma have anything to add to that. I can ramble about that for a while, but I'll spare y'all that.
Well, I think this is why we are doing this forum. We want people to start thinking about it's necessary that we need to start, you know, putting together a lot of the information that we are generating. And our future is going to depend on that. So there is a lot to do, and yeah, it will be fantastic. We can create that kind of database. I'm going to continue with the questions. We have two questions for Celeste, and it's from Peter Houghton. And first, he congratulates you for the talk, and the questions are: how do you correct the organic carbon content for the green schist phases metamorphism that you have in the rocks that you work? And the second question is, what about the distribution of the Precambrian organic matter? The deep sea floor may have been covered by microbial mats in the accent of grazers.
Hi, Dr. Houghton. Thanks for the questions. Both of them are great. So to answer the first one, several previous studies have looked at the effect that the metamorphism would have had on the organic content, and they've estimated that about 50 to 80% of the original content would have been lost based on the temperatures and the level of metamorphism that these rocks have experienced. So the numbers that I provide typically fall into a range based on that assumption. that we've lost 50 to 80% of what initially would have been deposited. And as for the second question, I think that's a great point, and it's still something that I'm looking into. The exact soils of this and the types it may have been is a really interesting point, because as you mentioned, the distribution and the types may have been quite different in the Neoproterozoic than what they are today. So I can't provide a definitive answer at this point, but that is a really great question, and something that I'm definitely looking into.
Nice. So we have a question from Michael Mayal, and it's for Javier. You mentioned that some of the deepwater currents are more permanent and others are more periodic. Are there differences in the structures or the bed forms associated with these different type of flows?
Yeah, that's a very good question as well. Yeah, I think so. Yeah, you can see this intermittent behavior on the sediment through emission through phase or reworking or condensation deposits, you know. Yeah, but this is really a surprise for us when we compare some of the study areas that they have this evidence of the intermittent in the bottom current at different scale. But the problem that we have at the moment is to date, especially the smaller variation in the behavior of the current. So we don't really know when this change is happening. We have some ideas that could be millennium or centennial scale, but we don't really have too much dating to really confirm the duration of the processes.
Wow, this is interesting. Now we have a question, and it's for Florian, and it was made by Ramon Lopez. What about using debris elements in ancient outcrops like plant remains to compare with the plastic particles in modern sediment? Could some plants remain have similar bulk density as the plastic particles, so to be able to compare them? If so, could this be used in ancient outcrops so they predict where the plastic particles are being deposited today?
That's a quite interesting idea, and I think in theory we could do this. We need to understand how these organic materials or these organic debris and also plastics are transported by different processes, by different flows. So if there are hydraulic equivalent or not, if a leaf is transported in the same way like a plastic film, or a piece of a tree like a plastic fragment, I think with experiments we could answer some of these questions. And there are already, I saw already papers, they described plastics in beach deposits, so really layers of different types of plastics which are incorporated in the stratigraphy. So there's already it goes already the other way, so we can already find plastics in deposits and learn from the processes there.
Wonderful. So we have one, Marco said that is fine, Aris, and he's going to contact you, or you can write to him and you can chat up more about this. Now we're going with the question from Tim Dencom, and he is asking to Celeste and Arif. Both showed that the organic matter can be concentrated in the lobes and the levee phases. Could the microplastics travel with non-anthropogenic matter and be much more concentrated there, as at the lobes or levees, than in the channels and other places listed by Florian, which are low sedimentation rate or have little net preservation? I think this question is actually for Celeste, Arif, and Florian at the same time. So I think let's go and start with the first part. It's just like you guys showed that either it's in the slope or it's in the levee phases, you find the organic matter concentrated.
It's less sure it's in the levees, and I showed it's in the lobes and distal lobes where these hybrid event beds tend to dominate. So, but there could be in the proximal sections as well. If the organic material is sort of, it's a high density material and can transport is a bed load and sort of can be deposited in relatively proximal settings as well as in the turbidites, you know. So so it can be, and the lobes and levees are sort of considered as the hotspots, you know, and data from the modern fan systems also shows this, you know.
Yeah, I think it would depend a lot on the size and type of the plastics. If they are very lightweight and low density, then they could be concentrated as well with clays in some of these distal lobes and levees. But you know, as it's been said, if they are high density, big pieces, then they would probably travel more also in the channel, in the channels, and be deposited with other sandy, high density grains.
I think Sophie in her paper showed that quite a lot of organics are deposited in the sand, actually in the axis of the channel, which was quite surprising. So I'm not so sure if all of the materials would end up in the distal part just because they are lightweight. And also in my experiments, I found that quite a lot of fibers were deposited in the sediments. Despite, I mean, if you think about the microplastic fiber, it's quite easy to keep in suspension, and this, even though we found a lot in the deposits. So I think this is quite an open question, where we can assume that they are in the distal deposits or in the levees, but we need to check that, I think.
Yeah, this is interesting.
When we talk about the plastics, so.
Of course. Yes, but it's interesting that we are trying to, maybe we are trying to use the same processes for different type of particles and they behave in a different way. Okay, so sorry.
I mean, physics are the same, so it should work.
Yes.
Fair point.
Yes, it's true. Okay, so the next question is going to be Lorna Strachan, and it's thank you very much for all the speakers. It really is interesting to see the shift in the research focus to using the deep marine processes and deposits to understand the environmental impact on humans. And this is a significant shift from just the hydrocarbon focused research. It will be interesting to find out if the researchers are now securing funding from their work from different stakeholders. I don't know who wants to answer that question. So thank you, Jody. And make a comment about that. We would like to see the panelists video. There is a question from Yvonne Speciala, and her question is: thanks everybody for the excellent talks. And the question is for Aris. Will you still be able to determine what the organic matter was sequestered in the hybrid beds? The rationale for my question is about the evaluating the amount of freshly buried organic matter and the potential of recycled organic carbon. Can stem from the eroded sedimentary rocks in the hinterland, and this is important for the carbon burial fluxes.
I think so. Thanks, Yvonne. There's a bit of disruption for some reason, but I think so. Sophie Haig, she did a really nice job, and she sort of showed where the younger sort of organic material can end up and where this older sort of from the older rocks can be recycled, and which part of the turbidite deposits. So there is a paper, I think so. I don't think I can add any further to that, because all of my organic matter was sort of old sort of organic matter. So all we were trying to do is to understand it from really process sort of perspective, where it's ending up. So it wasn't a different type of organic matter. Otherwise, I would have been confident to to comment on that. Yeah.
Okay, so I'm going to have, there are 3 more questions. One of them is from Guillermo Bossetti from the University of Strasbourg, and is for Florian. Do you have any idea whether there has been more detailed studies focusing on the amount of microplastic found in submarine channels and fans related to the highly populated regions versus the developed or underdeveloped countries? For example, offshore of the Pearl Rivers in the South China Sea, where they have the highest populated place on Earth?
Well, there are not many studies on deep sea microplastics at all. There is, in terms of channels or canyon systems, there are studies focusing on microplastics. I showed them, like from Song and Peng, what's published in Geology this year, a canyon in the South China Sea, where they found this 10,000 species per square kilometer. Then from Pier Domenico in South Italy, they looked at microplastics in canyon systems, which was also quite drastic, quite a lot. But microplastic, not that much, and especially then not looking at different regions and different sources to compare those. So we don't really have a good picture on where are microplastics in canyon systems and which canyon systems are particularly polluted by microplastics. This is something we need to find out, or we can. Yeah, it's also quite expensive to get these samples, though. Yeah.
Yes. So Florian, you have another question from Kate Gill. And do the plastic particles have the sort of electrostatic properties as in the clays, or are they relatively inert?
I think it depends on the type of plastic. I mean, we have thousands of different polymers with additives, and I think this plays a role. They might have some electrostatic charges, which might also influence how they are transported. But yeah, that's all I know about that.
Yeah, so Ramon Lopez mentioned, he is just throwing a question to the current discussion is about the effect of the geometry of the particles and should be considered instead of just density. The last question is from Giacomo Dalla Valle, and is, I have a question for Celeste, and he couldn't follow your presentation entirely, but he is asking, I focus in the slide and say, you don't need excessive anoxia to preserve the organic matter. Is this correct? This concept could also make us rethink our idea that we have, for example, in the case of the sarcopelic deposits.
Yeah, so I did mention that at the end. I sadly didn't have enough time to get into that, but we have done geochemical studies throughout the section that I've looked at, and we found that the basin was under offset conditions throughout this whole period of deposition. And even though it was offset, I do see significant amounts of tidal bend biltrate in these sediments. And so it does seem that we can get quite significant amounts of tidal bend sequestration, despite the fact that the basin was offset, even at depth. And that has to do, I think, with the rapid sedimentation. So levees have some of the highest sedimentation rates of any geologic environment, and that helps to just quickly filtrate these organic rich sediments below the point to which they'd be able to be degraded or oxidized. And so in this way, it is possible to get these organic rich beds without basin anoxia or other anoxic conditions.
Yes, so just to wrap up for this part of the forum, I would have to say that I like the comment Jacob asked, and I think this is going to be a food for thought for everybody, is that how do we convince the general public that dumping plastic in the deep ocean is bad, and combat any of out of sight or out of mind thinking, and how can sedimentologists contribute to achieve that? This is now becoming part of our task to do. So
I'm not sure. Yeah, what sedimentology can do we can just highlight or show how bad it really is, and that it's not out of sight, out of mind. So it has an effect. It has an effect on different deep marine environment, on animals there. So I think this is what sedimentology can do. To really achieve that there's a different thinking, yeah, I don't know how much sedimentology can directly contribute towards that. We are more focusing on looking at the problem rather than at the solution. if this is, if you know what I mean.
Yes, for sure.
To use less plastics and to reuse plastics and to have proper waste management. And there's not much what sedimentology can do to that. What we can show where the plastic goes and what the impact of the pollution is. And this, yeah.
And to add to your point and kind of reference one of the things you're showing in your presentation, right, is, you know, typically when people are, you know, people talk about how bad plastics are in the ocean, they show those big garbage islands in the ocean. It's like, you know, like you said, it's like, yeah, that's an issue clearly, and you can see it, but it's only a fraction of what's actually being buried. And so I think one of the key roles is in appropriately diagnosing the actual problem that's happening, right? Before even kind of coming up with it, we're never going to come up with a solution necessarily if we think that it's, you know, a fraction as bad as it actually is, or where the source is, or hey, you know, if you look offshore this delta, there's not that much because it all got potentially whisked away or relocated by bottom current. So I think that there's a huge role for the community to actually identify the genuine or actually refine and clarify our understanding of where these things are going and the impact that those have. And one of the points that I tried to make on this slide, where I kind of wrote some of the some bullet points, is I think the work that all four of y'all have shown already, or also already five of y'all have shown already, is that we need to more appropriately calibrate our models for carbon burial, for microplastics, and that starts with actually you know, the model's never going to be right if we don't actually have any data to build the model from. And so I think there's a pretty huge role in terms of making the sedimentological observations that you've already been showing today. So I think that's really exciting to see, and I think that'll ultimately potentially unlock, you know, there have been a couple questions on funding, new funding sources. Well, funding is going to be there when we start better understanding the problem. And so, yeah, right, there's a bit of a chicken and egg issue, but there's a lot of active work in the community kind of highlighting these issues. So I'm hopeful that the you know, the larger funding community responds because I think this work needs to be done.